Welcome you all. In this session, we are going to discuss the representation of single line diagram and per unit quantities in power system. Outcome. After successful completion of this session, the student would able to represent the power system in per unit quantities and in single line diagram. First, let us discuss the per unit quantities. The per unit value of any quantity is defined as the ratio of actual value of any quantity to the base value of the same quantity or the reference value of the same quantity. So once again, let me repeat. The per unit value of any quantity is defined as the ratio of actual value of any quantity to the base value of same quantity. Any quantity is converted into per unit quantity by dividing the numerical value by chosen base value of same dimension. The per unit value is dimensionless. It has no units. That is, the base value can be selected arbitrarily. It is usually assumed the base value as given below. Usually, the base value is chosen as base voltage is equal to the rated voltage of machine, base current is the rated current of machine, and base impedance as the base voltage by base current, base power as base voltage into base current. So this is how we choose the base value usually. But usually we can choose the base value arbitrarily, but even though it is chosen arbitrarily, we used to choose in this fashion. The value of base power and base voltage are selected, and their choice automatically fixes the other base value as the per unit kV is equal to actual value divided by base value. Base current IB is equal to base kVA divided by base kV. Per unit current I per unit is equal to actual value of current by base current. So the per unit current is given actual value of current divided by kVA B divided by kVB, and one it is again written as actual value of current into kVB divided by kVAB. Base impedance is given by base kV into 1000 divided by base current. Putting the value of base current equation ZB, we get ZB is equal to, that is the base impedance, is equal to kVB into 1000 divided by kVAB divided by kVB. So you'll be getting kVB the whole square into 1000 divided by kVAB. The base power is kVAB. Advantages of per unit system or per unit values. Manufacturers generally specify the ratings of equipments in per unit. Any unknown value can be easily assumed if the representation is in per unit. The per unit impedance of transformer is same irrespective of primary and secondary side is referred. This will not be in the case of normal ohmic representation. Per unit calculation is very simple based on the reduction in complexity. The value when represented in per unit lies in a narrow range. Therefore, enormous data can be easily identified. The per unit system are ideal for the computerized analysis and simulation of complex power system problems. For a three-phase transformer, the per unit calculation is same for both star and delta connected networks. So these are the various advantages of per unit system. The parameters of rotating electrical machines and transformers lie roughly in the same range of numerical values, irrespective to their ranges if expressed in per unit system of rating. It relieves the analyst of need to the circuit qualified to one or other side of transformer, making the calculation very easy. So we need not bother about the reference to primary side or secondary sides. So that's the main advantage of per unit system. So even though the per unit system has certain advantages, the major drawback of per unit system is some equation that hold the unscaled case as modified when scaled into per unit. The factors such as root 3 and 3 are removed or added by this method. The equivalent circuit of the components are modified, making them somewhat more abstract. Sometimes phase shift were clearly present in unscaled circuit vanishes in per unit system. So these are the major drawbacks in per unit system. Now coming back to the second representation, that is single line diagram. Single line diagram representation of power system. So what is a single line diagram? It is a diagrammatic representation of power system in which the components are represented by their symbols and interconnection between them are shown in a straight line. This is what a sample illustration is given in the diagram. Here you can see from the generating station to the load end you can see. So initially you have a generating station, then you have the transmission transmission line. So finally you have the load center. So you can see the here the circuit breakers are represented by boxes. Here you can see square boxes. So these things are the circuit breakers, and here star and delta, they are shown in order to represent the type of connection. So here it is delta and this one is star, and here the primary is star and the secondary is delta connected. So that you have two transformer, this is the transmission line, and here you have the generating station, and here you have the load center. The circuit breakers are represented by rectangular boxes. It is difficult to draw a line diagram of few components. So for simplification, the impedance diagram is used to representing the power system components. So the equivalent circuit of various power system components is shown. Here for generator, you can see for generator the equivalent circuit consists of the EMF, the resistance and the reactance value. So this is the equivalent circuit for transmission line. So here you can see the capacitance as well as you have the reactance. Next, all about the transformer. They have the primary side, secondary side and the core. So here this one is the primary and this with respect to secondary and this one with respect to the primary or magnetic circuit. And here the static load, here you can see the resistor with a inductor. And rotating load, here you have a EMF along with the same. Thank you.